Good morning. It is Tuesday, and we're going to continue with a little bit more speed calculation. But right now we have two do-nows. We have the one we're going to talk about here, which is the graph below shows the speed of a car over 4 hours. Use the graph to answer the following questions. What's the average speed? Right now, I know my total distance is 100, and that my total time where I can actually get a good data point is here at 3 seconds. So I have distance 100 over total time, 3 hours. I apologize. Okay, so we come up with 33 1/3 hour, or 33 1/3 miles per hour. So we've got that. Now, if the car continues to travel at this speed, how far will it travel in 9 hours? Well, we would simply take the 33 1/3 and multiply that speed times the time of 9, which would, yes, give us about 300 miles distance. All right. So today we're going to practice solving speed and distance problems. We're going to take about 10 minutes and continue to work on that sheet. I will learn to interpret speed graphs. We are going to hold on acceleration. I will describe the motion of the object based on the graph. So I can solve anything using the speed equals distance divided by time triangle. I can determine the x and the y axes on a graph, and I can figure out the slope. Then I can make up a story. So we're going to skip slide 3. Oh, but this is the review, sorry. How much time does it take a bird flying at the speed of 45 kilometers per hour to travel the distance of 18? So remember, that's distance over time. So I'm going to have 1800, 0 divided by 45. Okay, so if I take and I put into my handy dandy little 4-function calculator, you also have that option on your Chromebooks if you just Google calculator. So 1800 divided by 45, and that gives me 40 km/h. I'm still learning to use this thing, friends. All right, so there we go. So I'm going to exit the drawing. All right, and you have about 13 minutes to work on that. So we're going to, on the back side, how long does it take a bird flying at the speed of 45 kilometers per hour to travel a distance? Time. Well, time is distance divided by time. So we've got that one as well. Okay, so we did that. What do you notice? So take a few minutes and let's look at this graph. Okay, hopefully you've paused the 2-minute clock and you've looked at that, and you can notice that right here we have distance over time. Oh, that's like speed. So this is a speed graph. So this is what a fast and steady speed would look like. This is something increasingly gets faster. This is a steady speed. Maybe it's something rolled forward, and then it's kind of slowed down on a flat, and then maybe it kind of went downhill, returning back to 0. So that's what we did it. Right now, though, we're going to be looking at these speed graphs. This is the left side of slide 11 in your notebook. So you're going to drag these along with me. So what I'm going to do is ask you, what does acceleration look like? Very good. So you decided it was this curved piece right here. There you go. Oh, and then somebody said because that was acceleration, this should be, oh, nope. Oh, interesting. Accelerating. So if we go back to that first graphic, yeah, that's excellent. That gets us here. It's accelerating, going up, which means our slowing down graph would be this deceleration one. And then you got it. Our constant speed one would be here on the left. Oop, snug that up over. See, there you go. You got that. All right. So we're going to skip over acceleration graphs, and then if you want to look at acceleration graphs, you can. But what I want you to do is take a look at these motions. So if a student jogged slowly for 40 seconds and was able to cover 40 meters. So let's put that little thing in. So for 40 seconds and 40 meters. So that's right there. Okay, and then they stopped for 40 seconds to get a drink. So we're not going anywhere, so we're going to kind of come straight across. And then after that, they sped up to 60 meters. There we go. in 20 seconds. Oop. Let me erase a little of that because I got a little carried away there. Nope, I did that. I did that good. All right. Oh, nope. Got a little carried away. It's in there. All right. So this is what we could look like. I'm sorry it's not straighter, but it is what it is. So it would be the diagonal here, straight across, and then that quick diagonal jump. Okay? So what you've got going on here is there's that. So if I was running, then I slowed down, and then I was at a constant speed, and then I slowed down again. So we're going to describe the motion for these later on. So let's take a look. Let me take a, oh, yep, he is speeding up at a constant rate for 5 seconds. He is slowing down for 5 seconds. He is running at a constant speed, and he is slowing down for 5 seconds at D, and at E he stops to rest. So if I have to finish this drawing here, let's finish that drawing so it matches. So this is what we covered today in class, and we're sorry you missed, not as good, but it works well. So that's what we're talking about today, and that's where we're going to continue with speed. Tomorrow, we're going to come back and we're going to have a quiz. So make sure you're checking in your schools. You had to do now today. So tomorrow you click on this folder and this little, we have some extra credit. If you finish the calculation practices, there's some extra credit. Okay. And we're going to have a quiz about calculating speed and potential and kinetic energy tomorrow before we do an activity. So we're going to talk through that and we'll share that. Now that video may be posted tomorrow or Thursday, but we'll get it up. Have a great day and we'll see you all over the block days.